Everyone told you metadata governance was about training, better taxonomies, clearer dropdowns, more communication. But what if the real problem isn't the users? What if the real problem is that you put governance logic in the wrong layer entirely? Because the organizations fixing this aren't sending more emails, they're removing the user from the loop. And what they're building instead changes everything. Your governance strategy depends on a behavior your users stopped doing years ago. They don't tag files, they don't fill dropdowns, they don't classify content on upload. And yet your entire search compliance and AI readiness strategy assumes they do. The research on this is clear. The gap between what your policy asks and what your people actually do is widening every single day. And the cost of that gap is bigger than most organizations realize. When a file lands in SharePoint or Teams without metadata, it doesn't just lack labels. It becomes invisible to search. It becomes unreachable to compliance tools. It becomes useless to the AI agents your organization is about to deploy. You still pay to store it. You still pay to secure it, but you can't find it, govern it, or learn from it. That is what dark data actually means. Not deleted, not lost, just present and completely unreachable because nobody clicked the dropdown. The manual metadata crisis. Work changed. The way content gets created changed, and governance models built for 2015 can't handle 2026. Hybrid work transformed content creation into a continuous decentralized stream. Research from Tier 1 shows that roughly 42% of the workforce follows a hybrid pattern, 12% is fully remote, and the rest is back in the office full-time. That distribution, combined with mobile devices and cloud collaboration, means documents, chats, and files are produced across many tools and contexts all day long. Content doesn't arrive in batches anymore. It arrives in a constant flow from Teams, OneDrive, email, mobile uploads, and third-party integrations. In that environment, expecting users to consciously manage metadata through manual tagging gestures runs directly against how content is naturally created. People are in meetings, they're on mobile devices, they're switching between tools, and at the moment of creation, they're not thinking about taxonomy. They are thinking about the work. The content gets saved, the dropdown appears, and in most cases it gets skipped. The 2026 reality is that content volume has outpaced any human-driven tagging effort. Organizations with 10,000 users generate millions of files per year. Each file, in theory, needs classification for department, project, sensitivity, retention, and regulatory scope. That isn't a task humans can scale. It is a task humans were never meant to scale, and the assumption that they would was always optimistic. Consider the arithmetic. A mid-sized enterprise with 5,000 active users might see each user create or upload 5 files per day on average. Some days are heavier, some are lighter, but over a year that's more than 6 million files. If each file requires 3 metadata selections from drop-down menus, that's 18 million tagging decisions per year. Each decision requires the user to read the field, recall the correct taxonomy term, navigate the drop-down, and select the appropriate value. At 30 seconds per file, that's more than 50,000 hours of labor annually. And that's just for the files that get tagged. It doesn't account for the files that users skip entirely because they're in a hurry on a mobile device or simply don't see the value. The hidden cost extends beyond the time spent on tagging. When metadata is missing or incorrect, downstream processes fail. Search can't find the content. Compliance tools can't classify it. Retention policies can't apply to it. Analytics can't measure it. The organization still pays for storage, backup, security scanning, and e-discovery indexing of these files. But it receives none of the governance value that would justify those costs. Every untagged file is a small leak in the governance budget. And at enterprise scale, the leak becomes a flood. The hidden cost of human error in classification goes far beyond missing tags. When users do engage with dropdowns, they make inconsistent choices. 2 employees can classify the same document differently based on their understanding of the taxonomy, their risk perception, or their immediate incentives. One person marks a customer contract as general business, another marks a similar contract as confidential. Both are guessing, and both guesses become permanent because once a file is saved, it's rarely revisited to update tags as its usage or sensitivity changes. This inconsistency leads directly to what governance teams call dark data, files that exist but can't be found because they carry no useful metadata. Enterprise search initiatives fail because the majority of indexed items have little or no manual metadata, so queries and refiners return incomplete results. Users learn that the intranet search doesn't find anything, and they default to email or team search instead. The governance investment becomes invisible because the underlying data layer is empty. The enterprise search failure pattern follows a predictable arc. An organization invests heavily in a new SharePoint intranet or document management system. Information architects define detailed managed metadata columns for department, project, product, confidentiality level, and topic. Search configuration and navigation are built around these columns with refiners on tags. The launch is celebrated, training is delivered, and then reality sets in. Users store documents in Teams and OneDrive rather than in the official SharePoint libraries. Even within SharePoint, users skip or superficially fill out required metadata because it slows them down. Many items like chats, emails, meeting recordings, and loop components never pass through the metadata enforced libraries at all. What you get is a search experience that looks broken but is technically functioning correctly. The search engine is doing exactly what it was configured to do. It returns results based on the metadata that exists. The issue is that the metadata doesn't exist for most items. Search refiners based on tags show very small or skewed counts. Important content is invisible to taxonomy-based queries because it isn't tagged. Users conclude that the search doesn't work and abandon it. The organization has spent hundreds of thousands of dollars on a search infrastructure that can't find its own documents because the governance layer beneath it has nothing in it. The cost model for manual governance tells the same story. Manual metadata management is widely described as a hidden cost center because it depends on repeated human effort that becomes expensive and error-prone as data volumes increase. In the first year, manual governance looks cheaper because it avoids licensing and integration work, but its costs accumulate through analyst time, remediation, exception handling, periodic reviews, and the inefficiency of keeping metadata current in a constantly changing environment. By year 3, the total cost of ownership has usually overtaken any automation alternative. Remediation is the cost that manual governance teams rarely budget for explicitly. When an audit reveals that sensitive files were mislabeled, someone must find them, review them, and correct their metadata. When a search project fails because the indexed items have no tags, someone must retroactively tag thousands of documents or rebuild the search index with lower expectations. When a DLP rule misfires because of inconsistent labeling, someone must investigate the false positives, adjust the rule, and apologize to blocked users. None of these tasks appear in the original governance plan. They emerge as consequences of the metadata gap, and they consume resources that could have been spent on proactive improvements. A 2026 governance tool buyer guide explicitly warns that enterprise governance platforms can look affordable until implementation, training, and ongoing stewardship labor are included. The rule of thumb budget threshold is at least $150,000 over 3 years for enterprise-grade tooling to be realistic. Below that, the guide suggests a lighter native or open source approach may be more appropriate. That number is important because it frames the decision point. Manual governance isn't free. It is just paid in labor instead of licenses. And at scale, labor is more expensive. The shift from content management to content governance makes this even clearer. Microsoft describes content management at scale as a process that encompasses strategic planning, tool selection, governance and retention policy design, deployment and integration, and continuous training and optimization. Under this view, content governance isn't just about where files live. It is about how they're described, secured, retained, and surfaced to the right audiences over time in line with business, legal, and regulatory requirements. Without robust metadata, governance policies are hard to target, discovery is inefficient, and analytics or AI capabilities become unreliable. Manual tagging underdelivers on metadata quality precisely when governance is becoming more data-driven and fine-grained. Why dropdowns are a design failure? It is tempting to blame the users. They didn't fill out the form. They skipped the required field. They picked the default option. But the real problem is the interface itself. Drop-down selectors have been the default UI control for metadata fields in SharePoint file upload forms and line of business applications for decades. They promise consistency by constraining choices to a predefined taxonomy. But user experience research has repeatedly identified serious limitations when drop-downs are used for complex or frequent decision-making. The Nielsen-Norman Group's guidelines on drop-down design highlight several critical issues. Long drop-downs that require scrolling make it impossible for users to see all choices at once. Interacting menus where options change based on another field confuse users, and hiding or obscuring labels when menus are open deprives users of important context about what they are choosing. These patterns align closely with common experiences in metadata-driven forms, where users confront long lists of content types, departments, regions, or sensitivity categories, and struggle to quickly identify the correct choice. The same guidelines recommend avoiding drop-down boxes when typing would be faster, such as for familiar data like states, dates, or highly known options. They also caution against using drop-downs for data that's highly familiar to users because the motor memory they have for such information is disrupted by the need to hunt through a list. In the context of content tagging, these findings suggest that presenting users with multiple drop-downs for categories, tags, business units, and confidentiality levels slows them down and disrupts their flow, even when the underlying taxonomy is logically designed. Instead of being an unobtrusive way to capture useful metadata, drop-down-heavy forms become obstacles that users learn to circumvent or complete perfunctorily. The NN Group research emphasizes that drop-downs are particularly ill-suited when there are many items or when users must repeatedly interact with them during routine workflows. Content authors in Microsoft 365 often belong to this high-frequency category. They create, share, and update documents every day, often under time pressure. Requiring them to scroll through multiple long drop-down lists for each file is a fundamentally poor fit for their work patterns. Over time, this misfit manifests as partial completion of metadata, inaccurate guesses, or outright resistance to governance initiatives that are perceived as bureaucratic and disconnected from actual tasks. UX studies on enterprise software adoption underscore that tools and processes which add friction without obvious value are quickly sidelined, especially when alternatives exist. If tagging a file takes 30 seconds and the user doesn't personally benefit from the metadata, they will skip it. And if skipping is faster than doing it, skipping becomes the default behavior. Human factors play a role too. People are more likely to tag content accurately when they perceive a clear personal benefit, such as improved findability of their own files. But they're less motivated when benefits are abstract, like enterprise-wide reporting, or when they fear that tagging content as sensitive will expose them to scrutiny. In high-volume environments, fatigue leads to minimal tagging or reliance on default values. The first few files of the day might get careful attention. By the 20th, the user is clicking anything that makes the dialog disappear. This creates a two-tier system that most organizations never acknowledge. Diligent teams with strong process discipline produce well-tagged content. Everyone else produces chaos. And because governance policies depend on accurate metadata to function correctly, the policies only work on the diligent fraction. The rest of the estate operates in a metadata vacuum where search fails, compliance tools misfire, and DLP rules generate false positives or miss real risks entirely. The fatigue cycle is worth examining because it explains why training has diminishing returns. On Monday morning, a motivated employee might carefully tag her first 3 files of the week. By Wednesday afternoon, after back-to-back meetings and urgent requests, she is clicking the first option in every drop-down just to make the dialog disappear. By Friday, she has stopped looking at the fields entirely. This isn't laziness. It's the predictable result of asking people to make low-value decisions at high frequency. No amount of training changes the cognitive cost of those decisions. The only thing that changes is how quickly people abandon the behavior. The psychological cost is real and measurable. Decision fatigue research shows that the quality of human decisions deteriorates as the number of consecutive decisions increases. A knowledge worker who begins their day with careful, deliberate choices will make progressively worse choices as the day wears on. By afternoon, the same person who carefully tagged their morning documents is randomly selecting drop-down values just to reduce cognitive load. The metadata quality curve throughout a workday resembles a downward slope, not a flat line. And governance systems that depend on consistent human judgment across 8 hours of work are fighting a battle against human cognition that they can't win. Enterprise software adoption research confirms this pattern. Tools and processes that add friction without obvious value are quickly sidelined, especially when alternatives exist. If a user can save a file to their local desktop without any metadata forms, they will. If they can share through email instead of uploading to a governed library, they will. The governance system is competing with easier alternatives, and it's losing. Not because the users are wrong, but because the system was designed for compliance rather than for workflow. Governance teams often miss this dynamic because they measure adoption rather than quality. They track how many users have been trained, how many libraries have metadata columns configured, and how many documents have been tagged. These metrics look good in status reports, but they don't measure whether the tags are accurate, whether the coverage is complete, or whether the metadata is actually being used by search and compliance tools. A library with 1,000 documents where 800 have default or incorrect tags looks like 80% adoption on paper. In reality, it's 80% noise. The frustration this creates is palpable on both sides. Users feel burdened by forms that slow them down and deliver no personal benefit. Governance teams feel ignored by users who don't appreciate the importance of metadata. Executives see governance dashboards that show green status, while search remains broken and compliance remains exposed. Everyone is working hard. Nobody's getting what they need. And the root cause is a structural mismatch between how governance was designed and how work actually happens. The compliance implications are direct and serious. Data loss prevention solutions rely on accurate classification of data to detect and block unauthorized access, movement, or sharing of sensitive information. If sensitive documents are mislabeled as public, DLP rules may not trigger, allowing data to be exfiltrated or exposed. Conversely, if many documents are tagged as highly sensitive without justification, DLP systems may generate false alerts that overwhelm security teams and frustrate users whose work is blocked unnecessarily. Inconsistent manual tagging directly translates into inconsistent control application. Microsoft's own security messaging underscores this point. Insightful and intelligent classification is key to data security, and classification accuracy directly determines the effectiveness of protection measures. Sensitivity labels in Microsoft Purview serve as a foundation for a wide range of protective actions, from encryption and access controls to content marking and conditional access integration. If labels aren't properly applied or maintained, these controls can't function as intended. When labels are applied manually by end users, coverage is typically incomplete and biased towards certain workloads or teams that have received more training or are more compliance conscious. Other parts of the estate are left underprotected. Regulators and auditors want proof that sensitive data is identified and protected through repeatable processes. Manual tagging makes this proof difficult because individual decisions are rarely documented and even harder to justify. Automated classification, backed by centralized tools and published policies, gives you a defensible audit trail. Retention policies in Microsoft 365 depend on correct metadata scoping to retain or delete content on schedule. When manual tagging weakens that chain of control, both compliance exposure and operational risk grow. So if the user can't scale tagging and the interface is structurally flawed, where does governance logic actually belong? Graph API as the organizational nervous system. Microsoft Graph isn't just an API, it is a live map of your entire organization. Most people think of Graph as a way to query users, groups, and files, but that description misses what actually makes it powerful. Graph captures relationships, permissions, behavior patterns, and contextual signals in real time. It knows who created a file, what team they belong to, what project that team is assigned to, who has access to the document, and what other files are related to it. All of this happens automatically, without any user intervention, because Graph is the underlying fabric that connects every Microsoft 365 service. This is the critical distinction. Manual tagging asks the user to declare what a file is. Graph-based governance observes what the file actually is in the context of the organization. One depends on human memory, judgment, and willingness. The other depends on signals that are already being generated by the system every second of every day. The modern role of Graph API is best understood as the central nervous system for organizational intelligence. It connects SharePoint, OneDrive, Teams, Outlook, Azure AD, and the Power Platform into a single programmable layer. When a document is created in Teams, Graph knows the channel, the team, the members, the associated SharePoint site, and the broader project context. When an email is sent, Graph knows the sender, the recipients, their departments, and their access patterns. These aren't abstract connections. They are concrete, queryable relationships that can drive automated decisions. The shift from static storage to dynamic intelligence is what makes automated governance possible. In the old model, a file was a blob in a library with whatever metadata a user attached. In the new model, a file is an entity in a living graph, surrounded by signals that describe its purpose, audience, sensitivity, and lifecycle. The metadata isn't attached by a person, it is inferred from the graph. Context-aware metadata is fundamentally different from user-declared metadata. User-declared metadata is a snapshot of what someone thought at the moment of upload. Context-aware metadata is a continuous reflection of how the file exists within the organization's structure. A file might start as a draft in a project channel, move to a formal review library, and eventually become a record in a compliance archive. At each stage, its context changes. Its team ownership might shift, its sensitivity might increase, its retention requirements might extend. User-declared tags would remain frozen at the initial upload. Graph-derived context would update automatically because the relationships around the file have changed. This matters enormously for the next generation of enterprise search and AI agents. Traditional search depends on keyword matching and static metadata. If a file isn't tagged, it might as well not exist for most queries. Graph-powered search, by contrast, can traverse relationships. It can find every document related to a project regardless of where it's stored, because the project relationship is maintained in the graph. It can surface content based on who you work with, what teams you belong to, and what you're currently focused on. The search doesn't ask you to remember the right keyword. It asks the graph what is relevant to your context. The relationship model in Graph is what makes this possible. Every user, group, team, channel, site, file, and event is a node. The connections between them are edges. When a file is created in a Teams channel, Graph immediately knows the channel, the team members, their departments, their managers, and the projects they're assigned to. These relationships aren't static. They update continuously as people join and leave teams, as projects change status, and as access permissions shift. The graph is a living representation of how work actually happens, not a snapshot of how it was structured at the last reorganization. For governance purposes, this means that metadata can be derived from signals rather than declared by users. A file created by someone in the finance department, in a channel associated with the quarterly close project, during the week before quarter end, carries a wealth of contextual signal that no user would ever tag manually. The Graph API makes those signals available programmatically. The middleware can query them, map them to governance properties, and write them back to the file as structured metadata. The user doesn't think. The file is fully described. The depth of Graph's relationship data is what distinguishes it from simpler APIs that only expose direct properties. Graph supports transitive queries that traverse multiple relationship hops. A middleware query can start from a file, move to its creator, then to the creator's department, then to the department's assigned sensitivity level, and then to the retention schedule associated with that sensitivity level. This four-hop traversal happens in a single API call because Graph's OData interface supports expand and select parameters that bring related entities into the response. The middleware doesn't need to make 4 separate calls and join the results manually. It makes one expressive call and receives a structured object graph that contains everything it needs. This expressiveness reduces both latency and complexity. A middleware implementation that would require a dozen API calls against a traditional REST interface can often be accomplished in 2 or 3 calls against Graph. The difference matters at scale. A middleware processing 10,000 events per day makes roughly 300,000 API calls per month if each event requires 3 calls. If each event required 12 calls, the monthly total would exceed 1 million. The throttling limits, latency, and cost implications of that difference are substantial. Graph's relationship-aware design isn't a convenience feature. It is an architectural decision that makes enterprise-scale governance middleware feasible. Microsoft describes this capability in its document processing services, which use AI-powered classification to understand document types, extract key data points, and integrate results into workflows. These services support intelligent document discovery, classification, analysis, and processing using a pay-as-you-go model that lowers barriers to experimentation. But the real power comes from combining document processing with the relationship data in Graph. A document isn't just a collection of words that an AI can classify. It is an entity with an owner, a team, a project, a timeline, and a sensitivity profile. The AI can make far better classification decisions when it has access to that context. Power Platform's AI Builder further democratizes this pattern by allowing makers to train custom classification models and use them directly in Power Automate flows. A flow can take text input, call an AI Builder category classification model, and use the output in subsequent actions, such as routing or updating records. While the standard examples use manually triggered flows, the same pattern can be applied to content arriving from Microsoft 365 connectors. This enables low-code automation that enriches content with classification metadata based on custom models without requiring professional data scientists. It is a bridge between governance requirements and line-of-business teams who understand domain semantics. Text classification is one of the foundational tasks that makes this work. It involves categorizing text such as documents, emails, social media posts, or web pages into predefined classes based on patterns detected in the text. The typical workflow involves defining the objective, collecting text, cleaning and normalizing it, transforming it into numerical features, training machine learning models, and then using the trained model to classify new text. In the context of Microsoft 365 content governance, text classification can infer topics, business processes, or sensitivity levels from document content, email bodies, or chat messages, and map them to metadata fields or labels. Microsoft Syntax provides these capabilities as a managed service, but the same patterns can be built using Graph data as additional input features. What makes Graph powerful here is that it doesn't replace classification algorithms, it feeds them better inputs. A classifier trying to determine whether a document contains sensitive financial data will perform better if it also knows the document was created by someone in the finance department, stored in a finance team channel, and shared only with people who have finance roles. Those signals come from Graph. They cost nothing to generate. They are already there. The only question is whether your governance architecture is designed to use them. Automated content tagging systems use algorithms, often based on machine learning and natural language processing, to assign descriptive tags or metadata to digital content without requiring manual input for every item. The advantages include speed, consistency, and coverage. Machines can process large volumes of content far faster than humans, apply the same rules consistently, and be tuned to detect patterns that may not be obvious to casual readers. Automated tagging also supports dynamic updates. When classification rules change or new tags are introduced, the system can reprocess existing content to update metadata, something that would be prohibitively expensive manually. However, automation isn't a magic bullet. The accuracy of automated tagging depends on training data, model quality, and the clarity of tag definitions. Systems trained on generic data may struggle with domain-specific terminology or compliance categories. This is why practitioners emphasize combining automated tagging with well-defined taxonomies and governance frameworks, rather than treating AI as a substitute for human domain expertise. Effective implementations often use human-in-the-loop approaches, where automation provides suggestions that are reviewed or refined by experts, especially for high-risk decisions. Even with these caveats, automated tagging offers a path out of the bottleneck created by drop-down-based manual metadata entry. But knowing the context isn't enough. You need a layer that acts on it. Architecting the middleware layer. Think of middleware as a customs checkpoint for your content. It is a programmatic layer that sits between ingestion and storage, intercepting files before they reach their final destination and injecting governance logic in real time. Think of it as a customs checkpoint. Content arrives from Teams, OneDrive, email, or third-party integrations. Before it's stored, the middleware examines it, it queries graph for context, it applies classification rules, it injects metadata properties, it assigns labels, and only then does it release the content to its destination. The user saved a file. The system handled governance. Those two actions are decoupled. Azure functions are the natural host for this logic. They are serverless, event-driven, and integrate directly with Microsoft Graph through the SDK. They scale automatically with demand, which means a spike in content uploads doesn't overwhelm your governance pipeline. They also follow a pay-as-you-go model, so you can experiment with automated governance without committing to enterprise licensing before you know the pattern works. The Microsoft Graph SDK provides a middleware pipeline that's the key extensibility point for implementing robust ingestion architectures. The pipeline wraps HTTP requests and allows middleware components to be chained to add cross-cutting behavior such as authentication, retry, logging, and telemetry. The pipeline is ordered, meaning each handler wraps the next, and middleware can inspect or modify requests and responses, short-circuit execution, or handle errors. The built-in middleware components are essential for reliable content ingestion. The authentication handler injects access tokens obtained via Azure AD into requests, using client credentials flow for background ingestion jobs or delegated permissions for user-initiated actions. The retry handler automatically retrieves failed calls based on status codes like 429 and 503, respecting the retry after headers that Graph returns when throttling occurs. This is critical for ingestion workloads that hit throttling, which is almost inevitable at scale. The redirect handler follows HTTP 3xx responses, where Graph or underlying services redirect requests. The compression handler adds support for compressed payloads, which is particularly helpful for bandwidth-sensitive ingestion scenarios. Custom middleware is where governance-specific logic lives. The SDK explicitly supports custom middleware by implementing a handler interface and adding it to the pipeline. This is where you build logging and telemetry handlers for ingestion traces, circuit breaker-style handlers to pause ingestion on repeated failures, policy enforcement handlers for PII filtering or tenant-specific compliance rules, and multi-tenant routing for SaaS products ingesting content from many tenants. For governance implementations, the typical middleware stack looks like this. Authentication ensures the pipeline has the right permissions to read and write metadata. Logging captures every decision for audit purposes. Retry handles throttling and transient failures. A custom governance handler queries Graph for context, applies classification rules, and injects property bags. Compression reduces payload size. And the request finally reaches Graph to write the enriched metadata back to the file. The event-driven pattern is what makes this architecture practical. Instead of polling for new content, which is inefficient and always slightly out of date, you use webhooks or Microsoft 365 connectors to trigger the middleware when content is created or modified. The moment a file is uploaded to a SharePoint library, a Teams channel, or a OneDrive folder, an event fires. The Azure function wakes up, processes the file, and completes its work in seconds. The user experiences no delay. The governance happens invisibly. Most organizations miss this distinction. They think automated governance means running a nightly batch job that scans the entire estate and fixes whatever it finds. That isn't governance. That is cleanup with a schedule. Real governance happens before the file settles into storage, not after. The difference isn't technical, it is structural, and it determines whether your metadata is a foundation or a repair job. Webhook registration requires a subscription endpoint that Graph can call when changes occur. You register the webhook by specifying the resource you want to monitor, such as a SharePoint site or a Teams channel, and the callback URL where Graph should send notifications. The subscription is validated through a handshake process where Graph sends a validation token to your endpoint and expects it back within a short timeout. Once established, the subscription remains active for a default period, after which it must be renewed. Most implementations handle this renewal automatically as part of the function's startup logic. The notification payload itself is lightweight. It doesn't contain the full file content, which would be impractical for large files and high volumes. Instead, it contains the file identifier, the change type, and a change token. The middleware uses this information to query Graph for the details it needs. This separation of concerns is important because it keeps the webhook pipeline fast and resilient. If a single notification fails, the subscription doesn't break. The middleware simply processes the next notification and catches up on missed changes through Delta queries during its next scheduled synchronization. Microsoft 365 connectors provide an alternative trigger mechanism for Teams and Outlook. Connectors can post events to a webhook URL when messages are sent, meetings are scheduled, or files are shared. While connectors have some overlap with Graph webhooks, they're often easier to configure for specific Teams channels and can be set up by team owners without tenant administrator privileges. This makes them useful for pilot scenarios where you want to test the middleware on a single team's content before rolling out tenant-wide webhook subscriptions. Delta queries complement this pattern for keeping metadata fresh over time. A Delta query tracks changes in a resource since the last query, allowing the middleware to detect when a file has been modified, moved, or shared with new people. Instead of rescanning the entire estate, the middleware only processes what changed. This is essential for maintaining accurate context-aware metadata because a file's sensitivity and relevance often shift over its lifecycle. A draft shared within a small team is different from a final version distributed to external partners. Delta queries ensure the metadata keeps pace with reality. The middleware layer also integrates naturally with Microsoft Purview. Purview offers built-in pattern detectors, trainable classifiers, and custom information types that recognize sensitive data like credit card numbers, social security numbers, and health records. The middleware can invoke these detectors during ingestion, receive classification results in real time, and apply the corresponding sensitivity labels automatically. This closes the gap between discovering sensitive content and enforcing protection rules, so labels are applied at the point of creation rather than through retrospective cleanup. Real-time interception at the point of creation is the architectural principle that makes all of this work. The old model stores content first and governs it later, if ever. The new model governs content before it's stored. This isn't a minor optimization. It is a structural inversion. Governance moves from a retrospective cleanup task to a preventive control, and prevention is always cheaper than remediation. The Azure function implementation typically follows an event-driven architecture that scales automatically with demand. When a file is uploaded to SharePoint, the platform generates a webhook notification that triggers the function. The function receives a payload containing the file identifier, the site identifier, the user identifier, and a change token. It then authenticates to Graph using either managed identity or a service principal with application permissions. Managed identity is preferred for production because it eliminates the need to store and rotate client secrets. Once authenticated, the function queries Graph for the file's current properties, the uploader's profile and group memberships, and the containing site's metadata. These queries are batched where possible to minimize API call overhead. The function then applies the classification rules, which can be stored in an external configuration store like Azure App Configuration or a simple JSON file in blob storage. This externalization is important because it allows governance teams to update rules without redeploying the function code. A new retention schedule or a new sensitivity mapping can be applied by updating the configuration, not by pushing a code release. After classification, the function writes the metadata back to the file using Graph's schema extension endpoints. It then calls Purview or the Security and Compliance Center APIs to apply sensitivity labels if the classification warrants them. Finally, it writes a log entry to Azure Monitor or a dedicated logging table for audit purposes. The entire cold start execution typically completes in under 10 seconds, and warm executions complete in 2 to 4 seconds. For high-volume estates, the function can be configured with premium plans that keep instances warm and reduce latency to under 1 second. Once the middleware layer exists, you have to decide what to inject. Dynamic property injection. Property bags are one of the most underutilized mechanisms for lightweight metadata in Microsoft 365. They are essentially key value pairs that can be attached to SharePoint sites, lists, or items, and they provide a flexible way to store additional context without modifying the formal content type schema. In the context of automated governance, property bags are ideal for storing context-aware metadata that the middleware derives from graph signals. They are lightweight, queryable, and can be updated dynamically without requiring a formal schema change. This makes them perfect for the kind of rapidly evolving metadata that automated governance produces. Open extensions and schema extensions are not the same thing, and the difference matters for governance. Open extensions allow any application to add custom data to a resource, but they lack strong typing and discoverability. Schema extensions, by contrast, define a schema with typed properties that can be registered in the tenant and discovered by other applications. For governance scenarios, schema extensions are preferable because they provide stronger typing, better discoverability, and more reliable querying. When a middleware layer injects metadata using schema extensions, other applications and services can understand and trust that metadata because it follows a published schema. The injection process itself is straightforward in concept, but requires careful implementation. When the middleware intercepts a file, it queries Graph for the relevant context signals. Who created the file? What team do they belong to? What project is associated with that team? What sensitivity level does the project require? The middleware then maps these signals to property values and writes them to the file as schema extension properties. Registering a schema extension is a one-time administrative task that defines the metadata structure for your tenant. You create a schema definition that names each property, specifies its data type, and describes its purpose. For governance purposes, a typical schema might define project code, department, content type, and sensitivity level as string values, while retention years is defined as an integer. Once registered, this schema becomes available across the tenant and can be applied to any drive item or list item resource. Other applications can discover the schema by querying Graph's schema extension catalog, which means the metadata isn't hidden in a custom field that only your middleware understands. It is a published, typed, discoverable structure that any authorized application can read and write. The registration process requires administrator consent because schema extensions modify the tenant's data model. This is a security feature, not an inconvenience. It ensures that only governed, approved metadata structures are added to the organization's graph schema. Once approved, the schema is versioned and can't be arbitrarily modified without a new registration. This stability is essential for downstream applications that depend on the schema, such as search indexes, compliance reports, and AI training pipelines. What this means in practice is that your metadata becomes a first-class citizen of your data architecture. It isn't a hidden custom field that only one application understands. It is a published, typed, discoverable structure that any authorized service can query, filter, and reason about. That is the difference between a governance hack and a governance platform. For example, a project document created in a Teams channel might automatically receive properties indicating the project code, the department, the current phase, the assigned sensitivity level, and the retention schedule. None of these properties were selected by a user from a dropdown. They were derived from the organizational context that already existed in Graph. The project code came from the team's associated project, the department came from the team owner's department, the sensitivity came from the project's classification, the retention schedule came from a mapping table that the governance team maintains. Dynamic property updates are equally important. A file's context changes over time. A document might move from draft to review to final. A project might shift from active to archived. A security level might escalate after a merger or regulatory change. The middleware can detect these changes through Delta queries or webhooks and update the file's properties accordingly. This ensures that metadata remains accurate throughout the content lifecycle from the initial upload through every subsequent change. The Delta query and webhook pattern is what makes continuous freshness possible without constant polling. Delta queries track changes in a resource collection, returning only items that have changed since the last synchronization. Webhooks push notifications to the middleware when specific events occur, such as a file being modified or shared. Together, these patterns allow the middleware to maintain an up-to-date governance layer without the performance overhead of repeatedly scanning the entire content estate. This pattern scales because the work is proportional to change, not to total volume. In an organization with 10 million files, a daily full scan is impractical. But if only 1,000 files change per day, Delta queries and webhooks ensure the middleware only processes those 1,000. The computational cost remains manageable even as the estate grows, because growth in total storage doesn't translate to growth in daily change volume. Accuracy and evaluation are critical considerations. Automated classification hinges on metrics such as precision, recall, and F1 score, and different governance scenarios may prioritize different aspects of performance. In a compliance scenario, false negatives, which are failures to detect sensitive content, may be more costly than false positives. Models should be tuned accordingly. Governance teams must establish thresholds for acceptable error rates, design review processes for borderline cases, and involve subject matter experts in validating model outputs. Human-in-the-loop patterns remain important in high-risk domains, where automation handles baseline classification and human reviewers focus on exceptions, contentious categories, or policy changes. The hybrid model, where automation handles discovery, classification, and policy triggers while humans manage exceptions, taxonomy design, and high-risk review, is the most practical approach for most organizations. It reduces cost without fully removing human judgment from governance decisions that require business context. This aligns with governance frameworks that assign roles for data stewardship and accountability, ensuring that metadata and classification systems are actively managed rather than set and forgotten. But let's step back from the architecture and look at what this actually looks like in a real organization. What this actually looks like in practice. Consider a typical Tuesday morning. A marketing manager creates a campaign brief in Microsoft Teams. She attaches a budget spreadsheet, a creative brief document, and a vendor contract. In the old model, she hits save. 3 files land in the team SharePoint library. A dropdown appears for each file, asking for department, project, content type, sensitivity, and retention category. She has a meeting in 2 minutes. She clicks the defaults. The files are now stored with meaningless metadata that doesn't reflect what they actually are. 6 months later, the compliance team needs to find all vendor contracts created in the last quarter. They run a search filtered by content type and date. The new contract doesn't appear because it was tagged as general business document. It is dark data. It exists. It is stored. It is backed up, but it's invisible to the systems that need it. In the new model, the same upload triggers a completely different sequence. The file hits SharePoint. A webhook fires. The Azure function middleware wakes up and queries Graph. It learns that the uploader is in the marketing department. It learns that the team is associated with the Q3 campaign project. It examines the file content and detects financial terms, vendor names, and contractual language. It checks the project's classification in the governance system and finds that vendor contracts require a 3-year retention and a confidentiality label. All of this happens in under 5 seconds. The middleware then writes schema extension properties to the file: project code, Q3 campaign, department marketing, content type, vendor contract, sensitivity confidential, retention 3 years. It applies the appropriate purview sensitivity label automatically. It sets a DLP policy trigger based on the financial data detected, and only then does the file settle into storage. The user saved 3 files. Nothing else was asked of her. The governance happened in the architecture, not in the interface. Let us look at the technical sequence in more detail because this is where the architecture proves itself. The file upload triggers a SharePoint webhook that posts to the Azure Function endpoint. The function authenticates using the Graph SDK's authentication handler, which manages token refresh and permission scoping automatically. It then queries the Graph API for 3 categories of signal in parallel: the file's direct properties, the uploader's organizational context, and the team's associated metadata. The file properties query returns the file name, size, type, and a content preview that the middleware can scan for pattern matching. The uploader context query returns their department, role, manager, and project assignments from Azure AD. The team metadata query returns the team's associated project code, sensitivity classification, retention schedule, and membership list from the associated SharePoint site properties. All 3 queries complete in under 2 seconds because they're batched and the Graph API is optimized for exactly this kind of relationship traversal. The middleware then runs a classification pipeline. First, it applies deterministic rules. Project code Q3 campaign is assigned because the team is associated with that project. Department marketing is assigned because the uploader's Azure AD profile lists marketing as their department. Second, it runs pattern detection on the file content. The vendor contract contains financial terms, a vendor name, and contractual language that matches the trained classifier for vendor agreement. The budget spreadsheet contains numerical data in columns labeled budget, forecast, and actual that match the pattern for financial plan. The creative brief contains campaign terminology and brand language that matches the pattern for marketing creative. Third, the middleware resolves any conflicts. If the file content suggests financial document, but the team context suggests marketing project, the middleware applies a priority rule that marketing project context takes precedence for files in this team's channel. This is configurable per tenant and reflects the reality that organizational context often matters more than content analysis for classification accuracy. The middleware logs this decision for audit purposes, so a compliance officer can later review why a financial-looking document was classified as marketing rather than finance. Finally, the middleware writes the metadata. It creates a schema extension instance on each file with properties for project, department, content type, sensitivity, and retention. It calls the Purview API to apply the appropriate sensitivity label. It sets a DLP trigger on the vendor contract because it detected financial data, and it records the entire transaction in an audit log that includes the source signals, the classification rules applied, the confidence scores, and the final metadata values. The whole process takes 4 seconds. The user is already in her next meeting. When the compliance team runs their quarterly search, the contract appears instantly because its metadata is accurate and queryable. When DLP scans for sensitive financial data, the contract is correctly classified and routed through the appropriate approval workflow. When Copilot needs to answer a question about campaign spending, it can find the budget spreadsheet because the project metadata links it to the right context. When the retention period expires, the system knows exactly when to delete or archive the file because the metadata was set correctly from day one. This isn't a theoretical architecture. It is a pattern that organizations are already implementing. The pieces are all native to Microsoft 365. The Graph API is a first-party service. Azure Functions are a first-party platform. Purview is a first-party governance tool. The middleware is custom code, but it's built from standard SDKs and standard patterns. No exotic technology is required. The challenge isn't technical feasibility. The challenge is recognizing that the old model can't scale and that the new model is already available. The user experience is what makes this transformative. In the old model, governance is friction. It is a form to fill out, a drop-down to scroll through, a decision to make when the user is trying to do something else. In the new model, governance is invisible. It happens in the background. The user focuses on their work. The system focuses on compliance. Those two goals are no longer in conflict. Adoption resistance often surprises teams that expect users to celebrate the removal of metadata forms. Some users do celebrate. Others worry. They worry that the system is making decisions they can't see. They worry that their files will be misclassified and shared with the wrong people. They worry that automation removes their control over how their content is governed. These concerns are legitimate and must be addressed through transparency rather than dismissal. Transparency in automated governance means users can see what metadata was applied to their files and why. It means they can request a review when they believe a classification is wrong. It means they can view the audit trail that shows which signals were used and which rules were applied. And it means they receive notifications when their files are classified as sensitive or restricted, not because the system is punishing them, but because they deserve to know when their content carries elevated protection. Trust is earned through visibility, not assumed through automation. One file is easy. The real question is what happens when you do this for everything. Governance at the point of action. The old model of governance is retrospective. Content gets created. It sits in storage. Periodically, someone reviews it, maybe quarterly, maybe annually. They discover mislabeled files. They find sensitive data in public libraries. They uncover retention violations that have been accumulating for months. Then they remediate. This is governance as cleanup. And cleanup is always more expensive than prevention. The new model is preventive. Governance happens at the point of action, which means it happens at the exact moment content is created, modified, or shared. The middleware intercepts the file before it ever reaches static storage. It applies classification, labels, and retention rules in real time. There's no gap between creation and governance because the two are part of the same workflow. Shifting from retrospective review to real-time enforcement isn't a subtle improvement. It is a structural inversion that changes the economics of governance entirely. Retrospective governance scales linearly with content volume, because more content means more files to review, more exceptions to handle, and more remediation to perform. Real-time governance scales with the rate of change, which grows far more slowly than total volume. An organization with 10 million files and 1,000 daily changes processes 1,000 events per day. The same organization using retrospective governance must eventually review all 10 million files. Automated tagging ensures consistent policy application across the entire estate. In the manual model, coverage is patchy. Diligent teams produce well-governed content. Other teams produce chaos. The policies only work where the metadata is accurate, which means they only work on a fraction of the total estate. Automated governance eliminates this coverage gap by applying the same rules to every file, regardless of which team created it or how careful the user was. This consistency is what makes enterprise policies trustworthy. A DLP rule that says block sharing of confidential documents outside the organization only works if confidential documents are correctly identified. A retention policy that says delete general business documents after 7 years only works if general business documents are correctly labeled. When labeling is inconsistent, policies behave inconsistently. They miss risks they should catch, and they block work they should allow. Users learn not to trust the system, and they find workarounds. Governance becomes theater. The total cost of ownership comparison between manual and automated governance tells a clear story over a 3-year horizon. Manual governance looks cheaper in the first year because it avoids licensing and integration costs. Over time, though, the labor burden grows through analyst hours, remediation work, exception reviews, periodic audits, and the constant drag of keeping metadata current in a shifting environment. By year 3, the labor cost of manual governance at enterprise scale usually exceeds the cost of an automated platform. A 2026 governance tool buyer guide suggests that the rule of thumb budget threshold for enterprise-grade tooling is at least $150,000 over 3 years. Below that, a lighter native approach may be more appropriate. That threshold is important because it frames the decision point. If your organization is spending more than $50,000 per year on manual metadata stewardship, remediation, and search failure recovery, you have already crossed the line where automation would have been cheaper. The cost comparison becomes even clearer when you include the secondary costs that manual governance generates but rarely tracks. Time spent by compliance officers manually reviewing mislabeled files, time spent by IT support fielding search complaints, time spent by legal teams preparing for audits without reliable metadata reports, time spent by security teams investigating DLP false positives that stem from inconsistent tagging. These activities don't appear on a metadata governance budget line, and here's the part that most cost analyses miss. Every hour spent on remediation is an hour not spent on improvement. Your governance team is so busy fixing yesterday's mistakes that they have no capacity to design tomorrow's architecture. That is the hidden tax of manual governance. It doesn't just cost money. It consumes the time and attention of the very people who could be building something better. They appear on compliance budgets, IT support budgets, legal budgets, and security operations budgets. But they're all caused by the same underlying problem: metadata that was never reliable in the first place. Automated governance consolidates these costs. The middleware runs on Azure functions with predictable compute costs. The Graph API calls are included in standard Microsoft 365 licensing. The Purview integration uses existing sensitivity label infrastructure. The primary investment is upfront, building the middleware, designing the taxonomy, and training the models. After that, the ongoing cost scales with content volume at a far slower rate than manual labor would. An organization that processes 1 million files per year might spend $20,000 in Azure compute and licensing. The manual equivalent, at 30 seconds per file, would cost more than 8,000 hours of labor. At an average loaded cost of $60 per hour, that's nearly $500,000. The math isn't close. The hybrid model of automation plus human oversight also has a cost structure that manual governance can't match. In the automated model, human labor is reserved for exceptions, edge cases, and high-risk decisions. A governance team of 3 people can oversee an estate of 10 million files because the middleware handles the routine and only escalates the unusual. In the manual model, the same estate would require dozens of people across departments to tag, review, and remediate content continuously. The labor requirement grows linearly with volume. The automated model grows logarithmically because exceptions are a small fraction of total volume regardless of scale. The hybrid model of automation plus human oversight is where most organizations will land, and it's the most practical path for most estates. Automation handles the baseline: discovery, classification, lineage capture, and policy triggers. Humans manage exceptions, taxonomy design, and high-risk review. This keeps costs down while preserving human judgment for the decisions that actually need it. It also provides a natural escalation path. When the middleware encounters a file it can't classify with sufficient confidence, it routes the file to a human reviewer rather than guessing. The system is automated but not autonomous. The elimination of the coverage gap has a secondary benefit that's easy to overlook. When governance is consistent across the entire estate, analytics and reporting become trustworthy. You can query your content store and believe the results. You can answer executive questions about sensitive data exposure, retention compliance, and content growth with confidence. In the manual model, reports are always qualified with caveats about incomplete metadata. In the automated model, reports reflect reality because the metadata layer is complete. The transformation of governance teams themselves is another overlooked consequence. In the manual model, governance teams spend most of their time on low-value repetitive tasks. They review untagged files, they send reminder emails, they remediate mislabeled content, they argue with departments about compliance deadlines. It is tedious work that burns out talented people and produces modest results. In the automated model, governance teams become architects rather than custodians. They design classification rules, they tune taxonomy models, they analyze exception patterns, they advise the business on data strategy rather than chasing users to fill out forms. The work becomes creative and strategic rather than repetitive and adversarial. Morale improves because the team can see its impact in measurable outcomes rather than in spreadsheet rows of manually corrected tags. And the organization gets more value from its governance investment because the people are focused on design rather than cleanup. Microsoft Purview integration strengthens this further by providing a unified governance layer that spans structured and unstructured data across multi-cloud and on-premises sources. Purview's data map scans data assets and captures metadata, while the unified catalog allows organizations to build governance domains, curate data products, and connect data assets to business concepts. When the middleware injects graph-derived metadata into files, that metadata becomes visible to Purview's scanning and cataloging capabilities. The organization gets a single view of governance across all repositories, including the ones that were never tagged manually. The reporting transformation is one of the most immediate benefits of automated governance. In the manual model, compliance reports are always qualified. The governance team can report that 90% of files in the finance library have retention labels, but they can't report on the marketing library because nobody tagged those files. They can report that DLP rules caught 12 incidents last quarter, but they can't say how many incidents were missed because files were mislabeled. Every report comes with caveats, estimates, and gaps. In the automated model, reporting becomes precise and comprehensive. Because every file is classified at the point of creation, the governance team can report exact counts for any content type, any department, any time period. They can answer questions like, how many confidential documents were created in Teams channels with external guests last month? Or, what percentage of project files have complete metadata within 24 hours of creation? These are operational questions that manual governance can't answer with confidence. They are strategic questions that automated governance answers as a byproduct of normal operation. The confidence improvement ripples through every governance conversation. When the Chief Compliance Officer meets with the board, she can present numbers that are defensible rather than estimated. When the Chief Information Security Officer reviews DLP effectiveness, he can distinguish between policy failures and classification failures. When the Chief Technology Officer evaluates AI readiness, she can measure metadata coverage as a concrete percentage rather than a subjective assessment. Governance shifts from a soft assurance to a hard metric, and hard metrics are what justify budgets, drive priorities, and demonstrate value. But governance isn't just about finding files, it is about not getting fined. Compliance without human friction. Manual tagging creates compliance exposure in ways that most organizations don't measure until an audit forces them to look. Mislabeled sensitive data is the most obvious risk. A customer health record tagged as general business is invisible to DLP, invisible to compliance scanning, and invisible to retention policies. It sits in public libraries, gets shared with unauthorized users, and accumulates regulatory violations that nobody detects until the auditor asks the right question. Inconsistent retention is another hidden cost. One team applies 7-year retention to financial records. Another team applies 3 years. A third team forgets to apply any retention at all. When the organization is sued or audited, It can't produce a coherent record of what was kept, what was deleted, and why. The policy exists on paper, but the execution is fragmented across hundreds of teams and thousands of libraries. Auditors don't accept policy documents as evidence. They want proof that the policy was applied systematically. Automated classification and regulatory frameworks align naturally when the classification is derived from system signals rather than user guesses. GDPR requires organizations to know where personal data lives, who has access to it, and how long it's retained. HIPAA requires similar visibility for health information. Sector-specific regulations in finance, legal, and government impose additional metadata and retention requirements. All of these frameworks depend on accurate classification. An accurate classification at scale isn't something manual tagging can deliver. Sensitivity labels in Microsoft Purview are the foundation for a wide range of protective actions. They control encryption, access restrictions, content marking, and conditional access integration. When labels are applied automatically by the middleware based on content analysis and graph context, they're applied consistently and immediately. There is no delay between creation and protection. There is no dependency on user training or user attention. The label follows the content because the architecture was designed that way. The false positive problem is equally important. When manual tagging is inconsistent, DLP systems generate either too many alerts or too few. If users overtag content as sensitive, security teams are overwhelmed with false alarms, and users are blocked from legitimate work. If users undertag content, real risks slip through undetected. Both outcomes erode trust in the governance system. Users find workarounds. Security teams start ignoring alerts. The entire control layer degrades. Automated labeling specifically addresses the false positive problem through tunable thresholds. In a high-confidence scenario where the middleware detects a clear pattern like a credit card number in a known finance document, it can apply the label immediately with no human review. In a borderline scenario where the content contains ambiguous terms that might indicate sensitivity or might be innocent, the middleware can apply a tentative label and route the file to a human reviewer for confirmation. This two-tier approach reduces the volume of alerts that reach security teams while ensuring that nothing truly sensitive is ignored. The tunability is key. Different organizations will set different thresholds based on their risk tolerance, regulatory environment, and available review capacity. Automated labeling avoids this degradation by applying the same standards every time. The middleware uses defined classifiers, trainable classifiers, and sensitive information types that detect patterns like credit card numbers, social security numbers, or health identifiers. It can be tuned to favor recall over precision in high-risk scenarios, ensuring that borderline cases are flagged for review rather than ignored. And because the decisions are logged and traceable, auditors can see exactly why each label was applied and how the system arrived at that conclusion. Regulatory frameworks often require demonstrable, repeatable processes for identifying and protecting sensitive data. Manual tagging is hard to audit because it depends on individual decisions that are rarely documented. The user picked general business from a dropdown. Why? Was it intentional? Was it a mistake? Was it fatigue? No log entry answers those questions. Automated classification, configured through centralized governance tools and documented policies, provides a defensible basis for demonstrating due diligence. The middleware logs every decision. The rules are published. The models are versioned. The audit trail is complete. Retention policies and labels in Microsoft 365 can be used to retain or delete content according to prescribed rules, with logs and reports supporting accountability. But the effectiveness of these policies depends on correct scoping, which is tied to metadata and labels. When the middleware applies retention metadata automatically at the point of creation, the retention clock starts correctly from day one. Nobody has to guess retroactively about when a file was created or what category it belongs to. The metadata is accurate because it was derived from context, not declared by a user in a hurry. The compliance payoff extends beyond individual files to the overall data architecture. When metadata is consistent and complete, compliance tools can reason about the estate as a whole. They can identify concentrations of sensitive data, detect access anomalies, and predict retention load. They can answer questions like, how much health data do we have in Teams channels with external guests? Or which project libraries contain financial records that are approaching their retention deadline? These are the questions that regulators ask, and they're the questions that manual tagging makes impossible to answer accurately. Consider a GDPR data subject access request. A European customer asks for every file containing their personal data. In the manual tagging model, the compliance team must search across the entire estate using keyword queries and hope that files were tagged with the correct data subject identifiers. The search misses documents where the user skipped the metadata field, mislabeled the content, or stored the file in a personal OneDrive folder. The response is incomplete, the regulator is dissatisfied, and the organization faces fines for non-compliance. In the automated model, the middleware has already classified files by content type and detected personal data patterns during ingestion. The compliance team queries the metadata layer for all files tagged with contains personal data and the specific customer identifier. The search is exhaustive because the metadata is complete. The response is defensible because the classification was systematic. And the audit trail shows exactly how each file was identified, when it was classified, and what signals were used. The regulator sees a repeatable process, not a best effort search. HIPAA creates similar requirements for health information. Covered entities must know where protected health information lives, who has accessed it, and how long it's retained. Manual tagging makes all three requirements unreliable. Automated classification makes all three requirements traceable. The middleware detects health-related terminology, provider names, and patient identifiers during ingestion. It applies the HIPAA retention schedule automatically, and it logs every access event through Graph's audit capabilities. When an auditor arrives, the organization can produce a complete inventory of PHI locations, access patterns, and retention status without manual searching or guessing. Financial services regulations impose additional metadata requirements. SEC rules on record retention require broker-dealers to preserve business communications for specified periods. FINRA examinations test whether firms can produce complete records of customer communications and trading decisions. Manual tagging can't guarantee completeness because it depends on user compliance. Automated tagging can guarantee completeness because it happens at the point of creation for every file, every email, and every chat message. The retention clock starts immediately, the classification is consistent, and the audit trail is continuous rather than retrospective. And here is where it gets interesting for the future of your knowledge base. The search and AI payoff. Enterprise search in Microsoft 365 regularly underperforms when it depends on manual metadata. Most indexed items carry almost no useful metadata, so tag-based queries and refiners come back incomplete. Users figure out that the intranet search isn't finding what they need, and they switch to email or team search instead. The money spent on search infrastructure is wasted because the data layer beneath it has nothing to work with. This failure isn't a technical problem with the search engine. Microsoft Search is capable of traversing SharePoint, OneDrive, Exchange, Teams, and external connectors to return unified results. The problem is the metadata gap. When a file has no tags, no labels, and no context, the search engine has nothing to rank it by except the text inside the document. And text alone is a poor signal for relevance, sensitivity, and audience. Clean, machine-generated metadata changes the equation entirely. When every file carries accurate project codes, department assignments, sensitivity levels, and content types, the search engine can filter, rank, and surface results with precision. A query for Q3 campaign vendor contracts returns exactly the right documents because the metadata confirms the project, the content type, and the time frame. A query for confidential financial documents shared with external partners returns only the files that match all three criteria because the labels and sharing metadata are accurate. But the real transformation isn't traditional search. It is what happens when AI agents navigate a fully tagged knowledge graph. Copilot and similar tools don't just search for keywords. They reason about context, they infer intent, they connect related content across repositories, and they depend on metadata to do this accurately. When Copilot answers a question about project spending, it needs to know which files are budget spreadsheets, which are vendor contracts, and which are informal estimates. Without metadata, it guesses. With metadata, it knows. Microsoft's security messaging makes this connection explicitly. Copilot doesn't create new data risks. It exposes the ones you already have. And in many organizations, that means something uncomfortable. Your data architecture was never designed for visibility at this level. When an AI agent can query every document in your tenant, the quality of your metadata determines the quality of its answers. Bad metadata means bad answers. Missing metadata means missing answers. And in either case, the user blames the AI rather than the data layer underneath it. The shift from users searching for data to data finding users is what a graph-powered ecosystem enables. In the old model, you navigate, you search, you remember file names and folder paths. In the new model, the system understands your context. It knows your team, your projects, your recent activity, and your role. It surfaces content that's relevant to you without requiring you to formulate the right query. This isn't search optimization. It is a fundamental change in how knowledge flows through an organization. Traditional keyword search fails because it puts the burden on the user to know what they're looking for and how to describe it. Graph-powered context awareness removes that burden by letting the system infer relevance from relationships. A document is relevant to you not because it contains the right words, but because it's connected to your projects, your colleagues, and your current work. The graph makes those connections visible and queryable. The comparison between old and new search isn't just about speed or accuracy, it is about findability versus discoverability. Search finds what you already know exists. Discovery surfaces what you didn't know to look for. A well-governed knowledge graph enables both. When metadata is complete, you can find specific documents instantly. But you can also discover related content, past decisions, and relevant expertise that would have remained hidden in the manual tagging model. Consider a practical example. A project manager is preparing for a quarterly review and needs to understand the evolution of a product decision made 6 months ago. In the manual tagging model, she searches for keywords like product decision, and quarterly review, and hopes that someone tagged the relevant documents with the right project code. She finds 3 documents, misses the critical email thread where the decision was actually finalized, and spends an hour reconstructing a partial story from fragmented results. In the graph-powered model, she navigates through relationships rather than keywords. She finds the project node for the product initiative. From there, she traverses to all documents associated with that project, filtered by the decision-making time period. She sees the initial proposal, the budget approval, the stakeholder feedback, and the final sign-off email, all connected through shared project metadata. She also discovers a related risk assessment document that she didn't know existed, surfaced because it shares the same project context. What took an hour of frustrated searching now takes 2 minutes of intuitive exploration. This is the difference between a search index and a knowledge graph. A search index is a flat list of documents ranked by keyword relevance. A knowledge graph is a network of connected entities that can be traversed, filtered, and reasoned about. The search index depends on users knowing what to ask. The knowledge graph helps users understand what they should be asking. Both have value, but in an enterprise where most documents are untagged, the search index is crippled and the knowledge graph is the only viable path forward. The future of knowledge work depends on this transition. As organizations generate more content across more platforms, the human capacity to organize and find information reaches its limits. We can't train our way out of this constraint. We can't hire our way out of it. The only sustainable path is to shift the organizational burden from human memory to machine-readable structure. Automated metadata isn't just a governance improvement. It is a prerequisite for the next generation of knowledge work. The evolution of Microsoft Search reflects this shift. Early versions relied heavily on manual metadata and keyword matching. Modern versions incorporate signals from graph relationships, user behavior, and content context to rank results by relevance to the individual searcher. But these advanced ranking algorithms only work when the underlying metadata is rich enough to support them. If a document has no metadata, the algorithm has no signals to rank it by. It falls to the bottom of results or disappears entirely. The most sophisticated search engine in the world can't find a document that has no describable properties. The final piece of this payoff is AI readiness. Organizations are deploying AI agents across their estates at an accelerating pace. These agents need clean, structured, accurate metadata to function. They need to know what content is authoritative, what is draft, what is sensitive, and what is obsolete. They need to understand organizational structure, project timelines, and access patterns. All of this information lives in Graph. The only question is whether your governance architecture makes it available. Copilot for Microsoft 365 illustrates why this matters. When a user asks Copilot to summarize project status, Copilot queries the graph for project-related documents, meetings, emails, and chat threads. If the documents are untagged, Copilot must infer relevance from file names and text content alone. It might miss the critical budget revision because it was saved as numbers final v3 xlsx with no project metadata. It might include an irrelevant file because it happens to contain the word budget in a different context. The user gets a partially wrong summary and loses trust in the AI. With automated metadata, Copilot's queries become precise. It can request documents where project equals Q3 campaign, content type equals budget, and status equals approved. It can exclude draft documents, include only files from the current project phase, and surface content from team members rather than from people who happen to mention the project in unrelated emails. The summary is accurate because the underlying metadata is accurate. The user trusts the AI because the data layer beneath it's trustworthy. This isn't a Copilot-specific problem. Every AI agent that interacts with enterprise content faces the same challenge. Retrieval-augmented generation systems, which combine language models with enterprise search, depend on retrieval quality. And retrieval quality depends on metadata quality. A retrieval system that searches untagged documents is guessing. A retrieval system that searches a fully governed knowledge graph is knowing. The difference between guessing and knowing is the difference between an AI that occasionally hallucinates and an AI that consistently delivers. The knowledge graph concept is what separates old search from new discovery. In the old model, search indexes documents as isolated objects with whatever metadata was attached. In the new model, the graph indexes documents as nodes in a network of relationships. A budget spreadsheet isn't just a file with the word budget in it. It is a node connected to a project, a department, a time period, an approval workflow, and a set of people with permission to view it. These relationships are the context that makes the document meaningful. And they're the context that AI agents need to reason accurately about enterprise content. Organizations that build this infrastructure now will have a compounding advantage. Their AI agents will become more accurate over time as the knowledge graph grows richer. Their search will become more precise as metadata coverage expands. Their compliance posture will become more defensible as audit trails accumulate. And their governance teams will shift from reactive cleanup to proactive design. The investment in automated metadata isn't a cost center. It is the foundation that makes every other data-driven initiative more effective. The competitive dimension is worth stating explicitly. In the next 3 to 5 years, enterprise AI readiness will separate organizations that can leverage intelligent agents from organizations that are stuck with basic search. The difference between those two categories isn't budget or technology or talent, it is metadata quality. An organization with a clean, complete, automated metadata layer can deploy AI agents that reason accurately about its content, recommend relevant documents, summarize project status, and detect compliance risks. An organization with sparse, inconsistent manual metadata can't deploy those agents reliably, regardless of how much it spends on AI licenses. This is why the timing matters. The organizations that automate governance now aren't just solving today's metadata problem. They are building the data foundation that every future AI initiative will depend on. The organizations that delay aren't just maintaining manual tagging, they are accumulating technical debt that will make AI deployment harder, more expensive, and less effective when they eventually decide to pursue it. The gap between prepared and unprepared organizations isn't a temporary advantage. It is a structural advantage that compounds with every new file, every new project, and every new AI capability that arrives. So if this is where things are heading, how do you actually get there from where you are now? Building your roadmap. Transitioning from manual tagging to automated governance isn't a single project. It is a phased evolution that requires planning, piloting, and scaling. Organizations that try to automate everything at once usually fail. The taxonomy is too complex. The change management is too heavy. The exceptions are too numerous. A phased approach reduces risk and builds confidence. Phase 1 is audit. Before you automate anything, you need to understand what you have and where the gaps are. Run a scan of your content estate to identify where metadata is missing, where search is failing, and where compliance exposure is highest. Look for patterns. Are certain teams or content types consistently untagged? Are there libraries where metadata is complete and others where it's empty? Are sensitivity labels applied unevenly across departments? This baseline becomes your measurement framework. You will use it to prove that automation improved things. Phase 2 is taxonomy design. Define what matters, not everything possible. A common mistake is over-engineering the taxonomy with dozens of fields, nested categories, and complex rules that nobody can maintain. Start with 5 to 7 core properties that drive real governance decisions. Project association, department, content type, sensitivity, retention. These 5 properties cover most compliance, search, and policy use cases. You can add more later, but a simple taxonomy that's fully automated is more valuable than a complex taxonomy that's partially implemented. Phase 3 is pilot. Pick one content type and one team. Maybe it's project documents in the engineering department. Maybe it's contracts in the legal team. The key is to choose a group that feels the pain of manual tagging and will appreciate the automation. Build a single Azure function that intercepts files in their SharePoint library, queries graph for context, and injects the 5 core properties. Test it for 30 days. Measure metadata completeness before and after. Measure search accuracy. Measure user feedback. This pilot becomes your proof of concept and your training ground. Pilot success metrics should be specific and measurable. Metadata completeness before automation is typically between 10 and 30% for most enterprise libraries. After automation, it should exceed 95% within the first week. Search accuracy can be measured by asking pilot users to find specific documents using search and tracking whether they succeed. User feedback should be collected through a short survey that asks whether users noticed any change in their workflow, whether they trust the automated tags, and whether they would support expanding the system to other teams. These 3 metrics, completeness, accuracy, and trust, form the measurement framework that will guide your scaling decisions. Phase 4 is scale. This is where the pilot becomes production. Expand the middleware to cover core business content across the organization. Integrate with Microsoft Purview for sensitivity labeling and retention management. Add Delta query support to keep metadata fresh as files move and change. Implement webhook coverage for Teams, OneDrive, and email attachments. At this stage, you're building a production governance platform, not a prototype. Scaling requires attention to infrastructure rather than just functionality. You need logging, error handling, circuit breakers, and monitoring dashboards. You need a process for handling exceptions and edge cases that the middleware can't resolve. You need a support model that defines who responds when the middleware misclassifies a file, who reviews the audit logs, and who updates the classification rules when business requirements change. These operational considerations are what separate a successful production deployment from a promising pilot that never expands beyond its initial scope. Organizational change management becomes critical during scaling. Some teams will embrace automation because it removes a burden they never wanted. Others will resist because they distrust automated decisions or because they have built personal workflows around manual metadata. The governance team must communicate clearly that automation handles routine classification while humans retain control over exceptions. They must demonstrate that the system is transparent, auditable, and adjustable. And they must provide a simple escalation path for files that were misclassified so users feel heard rather than overridden by a black box. Phase 4 is scale. Expand the middleware to cover core business content across the organization. Integrate with Microsoft Purview for sensitivity labeling and retention management. Add Delta query support to keep metadata fresh as files move and change. Implement webhook coverage for Teams, OneDrive, and email attachments. At this stage, you're building a production governance platform, not a prototype. You need logging, error handling, circuit breakers, and monitoring dashboards. You need a process for handling exceptions and edge cases that the middleware can't resolve. Phase 5 is optimize. Use analytics from the middleware to identify where classification accuracy is low and where models need retraining. Refine the taxonomy based on real usage patterns. Tune the graph queries to capture additional context signals. Implement throttling best practices to ensure the middleware doesn't overload graph API limits. Add circuit breakers and retry logic to handle service outages gracefully. This phase never really ends. Governance is a living system that requires continuous refinement. Optimization metrics should focus on accuracy, coverage, and latency. Classification accuracy measures how often the middleware assigns the correct metadata on the first attempt. Human reviewers should periodically sample automated classifications and score them against a ground truth data set. Coverage measures what percentage of eligible files receive automated metadata within a defined time window after creation. It should exceed 95% for most content types. Latency measures how long the middleware takes to process an event from trigger to completion. It should remain under 5 seconds for user-facing workflows and under 30 seconds for background batch processing. Model drift is a real concern that governance teams must monitor. The classification models and rules that work today may not work next year because the organization's structure, terminology, and content patterns evolve. A model trained on last year's project codes will fail when new codes are introduced. A taxonomy designed for last quarter's product lines will misclassify documents from new products. Regular retraining, quarterly rule reviews, and annual taxonomy audits are essential maintenance tasks. They aren't signs that the system is failing. They are signs that the system is adapting. The long-term evolution of this architecture points toward increasingly intelligent governance. Today's middleware applies rules that humans designed. Tomorrow's middleware will learn from human corrections and automatically suggest rule improvements. Today's models classify based on patterns in the content and context. Tomorrow's models will reason about intent, predicting what a document is for rather than just what it contains. The foundation that organizations build now, the metadata layer, the schema extensions, the audit logs, and the feedback loops, is what will make those future capabilities possible. Common pitfalls are worth mentioning because they derail many automation initiatives. Over-engineering the taxonomy is the most frequent mistake. Teams try to replicate every manual field in an automated system and end up with complexity that's harder to maintain than the original problem. Trying to tag everything at once is another trap. Automation should start with high-value content types and expand gradually. Neglecting human in the loop for edge cases is a third pitfall. Some files genuinely require human judgment. The middleware should recognize when confidence is low and escalate to a reviewer rather than guessing wrong. The hybrid reality is that automation handles the baseline while humans handle exceptions. This isn't a compromise. It is the optimal division of labor. Machines excel at applying consistent rules to large volumes of content. Humans excel at interpreting nuance, handling exceptions, and making judgment calls. A governance system that tries to eliminate human judgment entirely will make expensive mistakes. A governance system that relies on humans for routine tagging will never scale. The middle ground is where the value lives. Microsoft Purview integration becomes critical at scale. Purview's pattern detectors, trainable classifiers, and custom information types create a solid foundation for automated labeling. The middleware can call Purview APIs during ingestion to scan content, receive classification results, and apply labels automatically. This connects content detection directly to policy enforcement, extending Purview's governance reach to every file in the estate, regardless of whether a user ever touched a dropdown. Throttling and resilience are operational concerns that become important once the middleware is handling thousands of events per day. Graph API imposes rate limits that vary by workload and tenant size. The middleware must implement retry logic with exponential backoff, respect retry after headers, and use delta queries to minimize unnecessary API calls. Circuit breakers should pause ingestion if repeated failures suggest a service issue, preventing a cascade of errors and back pressure. A circuit breaker works by monitoring the failure rate of Graph API calls over a sliding window. If the failure rate exceeds a defined threshold, such as 50% of calls failing within a 60-second window, the breaker opens and stops sending new requests. Instead, it returns a cached response or queues the event for retry once the breaker closes. This prevents the middleware from hammering an already struggling service and gives Graph time to recover. These patterns are well documented in the Graph SDK and should be treated as standard infrastructure, not optional extras. Security and permissions deserve attention during the design phase. The middleware needs application permissions to read and write metadata across the estate, which means it operates with significant authority. Principle of least privilege applies here just as it does for human administrators. The middleware should only request the specific permissions it needs, read user profiles and group memberships, read and write file metadata, and apply sensitivity labels. It shouldn't request mail access, calendar access, or administrative privileges unless those are specifically required for the governance rules it enforces. Permission scopes should be documented, reviewed regularly, and audited just like any other privileged access. Logging and observability are non-negotiable for production governance middleware. Every classification decision should be logged with the source file, the signals used, the rules applied, the confidence score, and the final metadata values. These logs become the audit trail that proves compliance to regulators and demonstrates value to executives. Dashboards should show daily throughput, classification accuracy trends, exception counts, and error rates. Alerts should fire when classification accuracy drops below a threshold, when error rates spike, or when the middleware encounters a content type it has never seen before. Governance without observability is governance without accountability. Change management is often underestimated in governance automation projects. Users who have spent years ignoring dropdowns may not notice when the middleware starts tagging files automatically, but power users who build workflows around manual metadata won't ice immediately. They may have SharePoint views filtered by specific metadata values, Power Automate flows triggered by manual tag changes, or reporting dashboards that depend on user-entered categories. Any of these can break when the middleware introduces new metadata sources or changes existing values. A communication plan that explains what is changing, why it's changing, and how existing workflows will be preserved is essential for maintaining trust. The roadmap isn't about buying a product, it is about shifting a mindset. The old mindset says governance is a user responsibility. Train them, remind them, enforce compliance. The new mindset says governance is an architectural responsibility. Build it into the system. Let the middleware handle the routine. Let humans handle the exceptions. And measure success by how little users have to think about metadata while their content remains fully governed. Measuring success requires new metrics because the old metrics no longer apply. Adoption rates become irrelevant when users aren't asked to adopt anything. Instead, measure metadata completeness as a percentage of eligible files that received automated classification within 24 hours of creation. Measure classification accuracy through periodic human review of random samples. Measure search effectiveness by tracking user search success rates and time to result. Measure compliance posture by the percentage of sensitive files that carry correct labels and the time required to respond to audit requests. These metrics describe outcomes rather than activities, and they align governance measurement with business value rather than with process compliance. The ultimate measure of success is whether governance becomes invisible. When users no longer think about metadata because the system handles it automatically, when compliance officers no longer chase missing labels because the coverage is complete, when search just works because the underlying data is clean, then governance has achieved its purpose. It has moved from being an obstacle to being an enabler, and that shift from friction to foundation is what makes the entire investment worthwhile. The dropdown isn't coming back, and that's a good thing. Manual tagging was never a governance strategy. It was a hope that users would do unpaid work with no visible payoff, and that hope is collapsing under the weight of hybrid work, regulatory pressure, and AI readiness. The alternative isn't more training or better dropdowns. It is moving governance logic out of the interface and into the architecture. When classification happens automatically through Graph API middleware, compliance becomes consistent, search becomes accurate, and your data becomes ready for the AI agents that are already on their way. If this changed how you think about metadata governance, follow me, Mirko Peters, on LinkedIn. I post regularly about M365 architecture, Power Platform strategy, and the governance patterns that actually scale. The next video dives deeper into the middleware implementation with specific code patterns and Azure function configurations. And share this with your team, especially if you're dealing with metadata chaos right now. The organizations that figure this out first will have an advantage that compounds over time. Because the real question isn't whether you can afford to automate governance. The real question is whether you can afford not to. The organizations that answer this question correctly will build knowledge graphs that power the next decade of enterprise intelligence. The organizations that delay will spend that decade cleaning up the metadata mess that manual tagging guaranteed they would have.